So welcome to Team DataFam Tableau User Group meeting number 11. This tug is a little bit different to other tugs where we meet when the presenter is available and not necessarily the audience, because we want to get some good presentations out online as well. So obviously these tugs are recorded. You're either here live or you're watching it on YouTube later, or you might be listening to the podcast. We'll have more details about that later. If you would like to present at the tug, please email me at team.datafam@gmail.com and we'll find a slot for you in the coming weeks. Today we have Harvey presenting Simplified Predictive Analytics with No-Code Solutions, and he's going to walk us through how to build dashboards with predictive analytics, look at the data analytics maturity model, and walk us through how to use AI agents in your analysis. So I'll hand it over to you and we can get started. So if I just stop sharing and you can start sharing.
Here, share screen. So do you see my screen?
Perfect, not a problem at all.
Yeah, thanks, Chris. Excited to be here to share my kind of story. You hear I was one of us being data analyst, working with different business intelligence tools. Then I kind of moved on because I wanted to see what's more in the world of data analytics. Then I moved to predictive analytics and finally into prescriptive analytics. And I'm going to define and show you exactly what I mean by these terms. Agenda for today is whenever I have the opportunity to talk about this topic, first, like you can find everything on Google or on ChatGPT today, but you cannot find maybe my experience or my view or what helped me to understand some complex concept from data analytics world. So I'm going to stick to those more than giving you some definitions that you can find anyway online. After I share my journey, I'll try to explain the data analytics maturity model and why it's important for every company today. Then I'm going to jump into the data sets, meaning I had some aha moments previously when I struggled to understand what's really the difference, like how to go from descriptive and analytics and dashboards into world of predictive analytics. So I try to share that story in a tangible way with you. Hopefully you will have this aha moment if you didn't have it already. And then I want to really inspire you or suggest that you try some low-code or no-code ML builders out there because it's so easy to be a citizen data scientist today, meaning you don't have to understand or know how to code something in Python to create ML models for you, your company, or your clients. And then briefly, I want to go to the demo, like to show you what I was talking about. And I'll try to condense everything in 30 minutes because from my experience, when I'm on the other side after 30 minutes, like you just don't follow with the freshness you have in the minute number one. So why is this the first slide? Because this is usually the first misconception with the companies preparing to do some AI. If you saw this movie, it's all about smart people think that they are not ready to have kids. In the same way, I realized that a lot of companies, they think they are not ready for AI because their data is not big enough or clean enough. So the fact is actually you really don't need big data per se. If you have 10 columns or 20 columns of your data, rule of thumb is if you only have 10 to 20 times as much as rows as columns, machine learning will probably have enough observations to pick up patterns and to create a quality ML model. So this is why this slide is here, because this is the first misconception. Another one is, I'm not sure what kind of data I need. And we are getting there. Basically, the same data may be labeled differently or prepared with the labels differently. You can use the same data as you're using for your dashboards today. So that's a good thing. As far as my story goes, I was my first job was creating Java reports for a big bank in Central Europe. Actually, I'm from Croatia, Central Europe. I moved to Ireland 6 years ago, and I needed a full week to develop some batch report in Java to deliver it on Friday. And on Friday, it was already old news because I started on Monday. That was my world in early 2000s. And then the first data revolution happened with tools like Qlik, Tableau, Business Objects. I worked with all of them afterwards. Revolution was because in drag and drop environment, as you are very aware, you can create charts, tables, dashboards without explicitly programming like every pixel or writing every SQL query yourself. But then in 2015-16, I kind of moved because I was in parallel always doing some kind of business intelligence projects. So I moved to predictive analytics. It was very new for everyone, really. And I really struggled to understand how to move there because data visualization is very tangible, and predictive analytics, whenever I read about it, it was, okay, now we have a model, accuracy 72% and period. And I was just confused, okay, how do I utilize it? What should I do next? Like, I had this what now moment with ML models for months, I have to admit. So I want to share this part of my journey because maybe that will help you to click into predictive if we want to click into predictive later on. Like I said, I'm not a big fan of definitions, but here is one and the only, I think, on these slides. Like, what is machine learning? The whole point is, in the old days, if I want to predict something, I would have to wrap everything around if, else, then statements, basically. Machine learning is different because it will see observations or rows in your data or pictures with visual AI, and it will translate that into mathematical models, and that's the key difference. These mathematical models, you don't have to explicitly program any what-if statements. It will be a model that will be able to predict some future outcomes based on trained data. For example, the most famous example is probably you are showing images of dogs and cats, exposing AI to the images, and when you say hundreds of times this is a dog and hundreds of times this is a cat, with every observation that you are showing, actually training ML model will be better in mathematical modeling, how to go from picture to the model, how does a dog look like, without if then else's from my side. But of course, every ML model will make mistakes. That's also something very important. This is a very famous example because lots of chihuahuas and muffins look alike. So if you train AI on chihuahua pictures, okay, this is a chihuahua dog. Sometimes it will say for a muffin picture, hey, this is also chihuahua, because every model will make mistakes. That being said, people are reluctant to put into production model that has 75 or 80% accuracy. They're fighting for 81 or 82% accuracy, which is usually nonsense. Because if your model is to predict something binary, like if email is spam, or if customer is going to churn, yes, no, this is a binary problem. So anything more than 50%, which is a flipping a coin, is much better than what you have today. So if you have 70-80% accuracy, that's a huge thing usually. Now I mentioned, so This is actually a screenshot from my first startup. I created the first startup in 2010 for data visualization. They called us actually Little Tableau back then, but I never get funded. So it's still a small company doing data visualization, doing right. So I was very big fan of human psychology, color theory, how we perceive data, Gestalt principles, all that good stuff to create a software like that. But when I moved to predictive analytics, I kind of struggle because this is very tangible. You think in business dimensions, business metrics, okay, aggregation is summary or average, and how should I visualize it so the end user will perceive the information that I want to give to my end user, my client or my boss or whoever. So in machine learning, you don't visualize anything really for the end user. I mean, you can some stuff, but these visualizations here, they're not for the end user. It's more for you. And I just want to introduce a few terms here. So if I'm doing a regression problem, that means I want to predict a number. I have many observations like these yellow dots here. And what ML does, it fits some kind of mathematical model, like I said before. So in a very linear fashion, this can be a linear model, so a line to the dots. And this model is not the best model because some polynomial model or more complex than a linear model can be a better fit for these dots. But it's always a good thing to be aware that there is something called overfitting in ML. So I'm just throwing some terms now. I don't want to dive deep into all of them. But overfitting is when you fit models so good for training dataset that it won't be able to generalize anything really on the new data that it didn't see after the model is trained. So my point here is data visualization, very tangible. You create something from dimensions and measures, and ML model is not tangible at all. You don't have to visualize anything. And that was bothering me at the beginning of my journey with ML. The only thing you can visualize is some kind of model accuracy to the stuff like this, but not to the end user. So, and I'm going to show you exactly what to do with ML models on the next slides. But now, maybe just one step back. Like, why do we do data analytics at all? In our day today, you don't probably ask yourself this question a lot, or maybe you are. That's a good sign. The data analytics world is basically built on 3 or 4 big blocks today. So here on the right, we have more complexity and technological maturity as we go to the right. But also as we go up, we have added value and degree of business intelligence that we can bring to our clients or our company. This is where we all start, and where I started 20 years ago, descriptive analytics. How many products we sold last year compared to the year before, what are our top locations in terms of revenue, and so on and so on. And you present different dashboards for different stakeholders, and this is telling you what happened. But and also you can dig sometimes very good why something happened with the modern BI tools. With different filters and different analysis you perform on your data. But if you want to add more value, you are hitting more complexity with the questions. Okay, now I know what happened, but what will happen if nothing else changes? Like, what is going to be our revenue next year? Or what is the product demand for every my product for the next 30 days, so I know, do I need to stock up or I'm okay with the stock for every product. So these kind of questions are answered with predictive analytics, and for predictive analytics you need machine learning, trained machine learning model on this same data that were basis for your dashboards. And something that is not so new as an idea, but new as it exists today, because you can combine generative AI and machine learning model patterns. That's what I'm doing in my new startup, is prescriptive analytics. Even if you know what will happen, if you know that this 100 customers are probably going to leave or unsubscribe from my service or churn, nothing is still telling you what you should do to stop that, what you should do to be better or to optimize any process. So this is the El Dorado of analytics, telling people what to do to optimize a process or to be better with some goal in mind. So I hope every company is going on this journey. Some companies are still in Excel and thinking about introducing the first descriptive analytics. And some companies that I talk to, they are asking me about prescriptive analytics because they just want to know, hey, what should I do next? What's my next best action based on my data? Maybe one good slide to understand what kind of questions and deeper questions you can start asking with machine learning and with prescriptive analytics compared to only descriptive analytics is this. So is this slide. Let's just, I won't go and read through all of this. Let's just mention lead scoring. Everyone basically has a CRM in place, especially in the bigger companies. And in CRM system, you have different leads, and some of that leads, they become customers. So if you go create a dashboard from that kind of data, you will be able to answer this kind of questions, like what happened, or you will create some average or sum per month, and you will create some dashboards. But with ML, you can ask very much deeper questions, like, okay, now it's Monday morning, I have 100 new leads. Which leads are most likely to convert, in the next quarter, but I can ask which of these 100 leads are the most likely ones to convert. Why is that important? Because I don't have a big sales team. I want to prioritize. I want to call the guys or girls with the most propensity to buy from me first. So I optimize my process. So this is where predictive analytics come in, and you will be able, with ML model, to predict every new observation, and observation in our example is a lead in CRM. But also with explainable machine learning, which is very important concept, you can understand in general, after I trained the model on CRM data, I can understand what are actually the key drivers driving conversion or propensity to buy from me. It's very important because you can have like 30, 50 columns in your CRM data, and you don't have a clue which one are important ones. What are the important factors? Maybe you think that the important thing is the lead source, and maybe it's completely irrelevant to conversion. You don't know that if you don't have an ML model in place. And finally, with prescriptive analytics, based on all of these building blocks, you can actually ask questions like how I can prioritize my processes to convert more. So based on all of these key drivers and ML model patterns, you will be able to understand exactly based on your data, and that's very important. It's not general ChatGPT question, it's based on your data. So based on what we saw happening in your CRM, this is what you do in order to optimize and convert more customers. And I'm going to show a very similar example by the end of this presentation. Point of this slide is not to confuse you. It's kind of heavy, but there are no code tools out there today, low code or even no code tools that are going to, when you connect to the data, everything after that is going to be automated. You don't have to do anything because no code environment will do this for you. And by the end of model generation, which is as easy as creating a chart in Tableau, you will be able to predict future outcomes, and you will get actionable insights or prescriptive analytics in such tools. So that's how you actually become a citizen data scientist. One part of my motivation to build such a tool is because there's a big shortage of data scientists out there, and they usually don't do always very sexy stuff within the company. They are doing something they have to do. They don't have the bandwidth to create models on scale usually. That's my experience. And the idea is if you give ML capability to build this kind of models to data analysts that are not Python guys or girls, so you don't have to understand Python to become a citizen data scientist with the tools like this. And I think data analysts are perfectly well suited for this kind of job, because you own data, you understand data sources, you sit up on top of all of that data infrastructure to create some kind of dashboards. Now, basically, the same data sets with good tools, you can create ML models and open the whole new world of predictive and prescriptive insights and value for your company or your clients. My point here is like, you don't need to have or understand a theory of numbers in order to use calculator. In the same way, you don't have to understand every linear algebra stuff there is out there on the universities in order to build ML model with tools like this. So they exist. In most of no-code environments, you will find different possible models to build. So I just want to, in order to become a data scientist, like I said, you don't need to understand the every linear algebra stuff, but you do need to understand just a few terms. That's why I'm throwing them here, maybe to inspire you, because with these 5 models, from my experience, you can answer 90% plus use cases and answer different predictive business questions. If you want to predict some numbers, you're talking about regression. If you want to predict classes or strings, you're talking about classification. Specifically, binary classification is when you have two, in your question or target column, you have 2 states, 2 possible values, like customer is going to churn, yes, no. Email is spam, yes, no. True, false. Multi-class is I want to classify a breed of a dog. So I have 20 different breeds from a picture. Time series is when I want to predict something that's happening in time. So I want to predict something in the future. Let's say it's a subset of regression type of the models. So all this modeling is basically available in low-code and no-code tools today. And with some of them, you can ask questions like this. So this slide, the point of this slide is to help you understand what kind of questions can be answered with this kind of classification. So with 2 states, or multi-classification with more states on a target variable, or with regression, which is all about predicting numbers. Now, very important thing is to understand your objective. It's very easy to get lost in the potential, really. That's what I find out in hard way talking to prospects, because usually their angle is they don't know what they want from ML or AI, and their answer is probably something like, I need 2 kilos of AI. For what? I don't know. We just want to start with the AI. But you really need to start with an objective, clear question. Something like this. I want to understand if my marketing campaign is going to be successful. That is clear objective. With this clear objective, you understand what kind of data you need to prepare, and then you understand what kind of model you need. Is it classification, regression, something else? So very important to have a clear objective and start small, and then you can polish your model and create your second model and third model in no time after that. Otherwise, you will be probably lost in the opportunity. Why is very important to understand business question is this is a good example. So this is a diamond data set. It's maybe not very relevant. I suppose no one listening to this is selling diamonds, but it's a very famous Kaggle data set for machine learning. And it's very famous in data science space. So for every row is one diamond. We have diamond ID, carat weight, cut, diamond color, and so, and diamond price. So now, if my question is, I want to train ML model on this data, and I want to understand when I have a new diamond in my hand, I'm going to measure all of this, color, clarity, polish. I want to understand what should be the price of this diamond after I train a model. That means price is my target column. That means I'm going to do regression. But on the same data set, that's what was confusing for me at the beginning. From the same data set, if I change my question to, I want to train an ML model to understand what is driving the ideal cut from the diamonds. And when I have a new diamond in my hand, I know the price, I can measure all of this stuff, but I want to predict what will be the cut of that diamond. Then my question changes and my target changes to cut. So I'm not talking about regression, now I'm talking about classification. So same data set, not unlimited, but a lot of possible models from the same data set based on your business question. And when I have a trained model, if I'm talking about predicting price, then this is my new diamond in hand. This is color, this is symmetry, this is clarity. This is the price based on all historical observations. This is the price expected by the model from everything that the model saw before. And this is another price on the same carat weight, but here the color is D and here the color is F. Historically, when the color is F, the price is much lower. So this is how you operationalize ML. You create predictions based on ML model. You don't create dashboards for your end clients. And if I did another thing, if I did a classification on the same data, then it will look like something like this. If this is my new diamond I hold in hand, I know the price now, I know the polish, symmetry, etc. Prediction is that cut is probably good, and then the second choice is very good. And this is the percentage how certain the model is in predicting a class, which is a cut for this diamond. And for this another diamond, the model is predicting that cut is signature ideal, and it's pretty sure that it should be signature ideal based on all the past observations of similar diamonds like this one. So again, from the same data set, you can do even more. What we talked about in the previous slides is supervised machine learning, when you exactly know what is your target. Your target was cut or price or color or any other column really. But if you don't have a target in that sense, if you just want to cluster or segment stuff, then you are doing unsupervised ML. And if I want to segment or cluster my diamonds with carat weight and price, my gut is telling me it should be somewhat linear. And this is what you can expect. So ML is going to find natural groups or clusters. It's 5 of them. And the purple I renamed to most valuable because this is the weight and price plane. So without you lifting a finger, ML is going to find the number of natural clusters for you. It's going to create the cluster for you. And again, without you lifting a finger, without you putting any if then else, like if price is more than 10,000, then that's a very valuable diamond, because you can do that, but it's not ML. And next week, the market can change and your model is not right because you put hard-coded $10,000 price as the boundary for some clusters. So again, same data set, completely different business question and completely different ML for different answer. Excuse me. One of the last important questions that we got very often is, how can I trust my ML model? So to explain it very simply is, when we train the data, let's say we have 1 million of diamonds, let's say. We take 80% typically in ML modeling, 80% for training, and 20% we pulled out. And ML model never saw this 20% of diamonds. And after the model is trained, then we are predicting the model. What is model going to say for every row in the 20% of test data set? And because we already know the answer, we can see when and where the model was correct or incorrect in prediction. And based on this, basically you have the most basic measure of how model is good, and that's the accuracy. It's the ratio of correct and incorrect answers based on test data set 20% that we pull out. So it's a very important concept because people usually ask, how can I trust ML model? This is how. This is a slide I have to include because in the last few months, it's a jungle out there. People, C-level executives, they answer to, if they want to predict churn or how to improve churn or lead scoring or anything in their company, they think they're going to solve that with ChatGPT or Copilot or anything similar. The answer is no, you are not, because if you ask this question to ChatGPT, okay, this is my customer, I'm a telco company, please predict what's the propensity that this customer is going to churn. 1 year ago, ChatGPT is even it provided some kind of answers which is totally wrong, because ChatGPT is not going to train your ML model. At least today, it's admitting, hey, for that I need ML model, and I'm not going to create and deploy ML model for you. So whenever you need ML model, ChatGPT and similar tools are not going to give an answer. This will be the answer in LLM, and this will be the answer after you really do have machine learning model based on your data. So it's very important concept today because, like I said, it's a jungle out there. People are very confused and they think LLMs, they have superpowers. It's just a model itself. It's just a language model. And that's it. Incredibly helpful. I'm using it every day, but for different tasks, not for this, not for predicting stuff or even prescribing stuff. Now I'm moving to a demo, but just to set the scene for a demo, this will be the data set. So let's say we are a telco company. I have data on my customers with different columns, like type of contract, is it paperless billing, yes, no, payment method, and so on, monthly charges, and the most important column in terms of ML will be churn, yes, no. So the first two customers churned from me. The third one, no, sorry, didn't churn. So the churn is no. And the third one churned. why I said this is the most important column for ML, because this is going to be our target column, like I mentioned in Diamond dataset when we have target, price, or cut. So this is called data labeling. If you don't have, imagine if you have telco company, you have all this data, but you don't have churn column, and you need one. It's usually very easy to create it in SQL query based on some other property, and that's called data labeling. So this is only thing you need really to prepare for ML modeling. And if you are going to try to use descriptive analytics for understanding churn in this company, the best you can do is really to create different charts and dashboards to count churn by gender or internet service type or any column here really. But it's not going to help you with the prediction. I have a new customer, or with the prediction, like every Friday, I want to go to all my customers in telco and I want to understand what's the probability that they're going to churn from my company. For that, you need ML. So it's demo time. Let's jump to. So I'm using Graphite Note. There are other low-code or no-code tools in the world today, but this is full no-code tool. I want to open this model based on the data set I just showed you. So this is the data from telco that I showed you on the slide, and this is my churn column. Okay, I have 7,000 observations, 23 columns, and back to my model. In no-code environment, if I want to create a model, I just have to go to a few steps. First, the most important is, what is my target? If you remember, that's my label, that's my churn, yes, no. So this is my target, and I want to create ML model around my target. Churn, yes, no. Then basically you can go next with the defaults. You can include or exclude some columns. Some columns are automatically excluded from ML modeling because they are not fit for the model. You can play maybe with some advanced parameters if you want to know more. But if you don't need this kind of flexibility, you just go with the defaults. On the basically last step, you can define your goal based on data. So what will be your goal for prescriptive analytics that we are offering? And my goal is to increase the frequency of churn no outcomes based on my data. And then you run model. The model is, of course, already run, but it took, let's check, it took probably a few minutes to get to this screen. And I won't go to all the tabs here, but I just want to show you that what is auto ML. So Graphite Note automatically went through all these algorithms and find out the most accurate one, which was logistic regression in this instance. And it took only 47 seconds to go through all of them to train the model on the logistic regression algorithm and to create all the key drivers. So it was very fast, faster than I expected. I thought it was a few minutes. Let me just show you how to start using ML models, but more visually with this kind of tools. Now, I want to see key drivers to churn. And it seems that tenure, how long someone is with us, total charges, contract type are very important drivers for churn. Some other columns are not so important, like phone service or internet service. They're not so important as this one. So this is the first insight you have. Then for every column in our data set, we have all the sweet spots. Like I can see that when tenure is in this bucket, the likelihood of being churn is more than 2 times increasing than on the other buckets of tenure. Like, let's see the contract. When the contract is month to month, it's 6.3 times more likely for customers to churn than with 1 year and 2 year contracts. And then with all these columns, you start building a sweet spot and ideal persona for churn yes or churn no, which is incredibly valuable to strategize around all this information. And let me just jump straight to prediction part, because right now we have ML model, it's deployed, and similar like with the diamonds, I want to predict this customer, is he going to churn yes or no? It's almost 50-50 for this one, but what if this customer was 60 months with us, and it's on 1 year contract, it has paperless billing? The answer will be something else. So in this fashion, or through the APIs, if you want to automate stuff to intelligent AI agents, like in this Postman, you can just send something to API, and you're going to get basically this answer for every customer, and AI agent can create some other intelligent stuff based on this information. But it's very important for AI agents to have this kind of information, because if they just talk to LLM doesn't know anything about your ML model and didn't see your data, so it cannot predict your churners. Yeah, this is my just example how to call and send something to the API to the model. This is actually machine failure model with the air temperature and process temperature. So we send the values, and the result is going to be that no failure, basically 99%. At this instance, we don't have to worry. But if my temperature goes to 310 kelvins, then I'm probably in a big there is a big propensity, let's say, to have heat dissipation failure based on past data. I know I just switched from churn models to some other model, but I just want to show you how to operationalize ML, how to think about these predictions. You can also do batch predicts. Like imagine these are my customers in my telco company, and for everyone, each line, I want to know the prediction. Are they going to churn, yes or no? And I can go here. I can select this Excel file, and here something is going on with my, I don't know. Okay, there's a table there for every row showing you that we are predicting that this customer is going to churn yes, and ML model is 64% sure that is going to be yes. You have this result for every row that you provided, or I just provided to ML model. And now on top of this, like this was so good like 3-4 years ago, but it's not enough today. Now we are talking about prescriptive analytics, and it really resonates with everyone that we talk to. Like even if we do have predictive analytics based on our data and all these key drivers, we are able to create incredibly powerful narrative about actionable insights and what to do next. First, everything that we explained here on the key drivers, there is a full narrative of all the sweet spots and everything based on all columns that we have on our ML model. And based on all these statistical patterns and our IP is what we feed generative AI to produce something like this. You have strategic summary, key observations about every column, and now it gets interesting. You have strategic direction, because remember, my goal is to decrease occurrence of churn now. So you know exactly from this what to do. And I remind you, this is not based on some general stuff. This is exactly based on this client's data. For example, here we want them to actively promote electronic check usage because we found it decreases by this amount churn in the company. So based on all these sweet spots that we feed generative AI to, we created a prescriptive analytics with different objectives, OKRs, KPIs to track, what exactly to do in order to achieve a goal, and our goal is to decrease the churn. So I'm going to stop here. It's longer than I expected, sorry about that, but I'm going to stop here and Chris, back to you.
Awesome, thank you. I was enjoying it, so it doesn't matter.
Okay, thanks.
That was pretty cool. I liked it. It was a good walkthrough on what to expect from machine learning. We don't have many people left in the chat, but there's been no questions either. So I don't know if people have been enjoying it or not, but there was no questions in the chat at all. So we'll move on. And if there is questions in the chat,
I was so transparent, so no questions at all.
But as I said, you were explaining it well. Oh, okay, Wenbin has a question, so we'll just wait for that to come in the chat. I can unmute you. Why not? Why not we do that? So on my side, you are unmuted, and you just have to unmute yourself now, and then you can talk.
Can you hear me?
Hey, yes, can.
Hey.
Hi, thank you so much for the presentation. I think it's very insightful. So, so just a background about myself also, because I just recently graduated from university with a specialization in business analytics. So the content is quite relevant to me, and I think the question I have is more of like, let's say in 5 years' time, right? We know the capabilities of generative AI, and there's so many of these like no-code solutions coming out. I think my question is more geared towards in 5 years' time. Where do you see how will the role of a business or data analyst change? What are kind of the skills that you feel is still required?
Congrats on your career path. I think what you saw in the upper right corner on this slide around prescriptive analytics is the absolute killer, because we never felt that much enthusiasm when we talk to someone, unless we mention, hey, by the way, we can tell you exactly what you should do. So I think go from just building a dashboard and explaining what happened, if you will be able to say what is going to happen and how to change and what to change in order to be better or to optimize something, I think that's where the industry is going. In terms of tool sets or what you should be researching, I think many people dive too deep too soon into like linear algebra if they want to do like predictive analytics. And just like I said, you don't need to understand everything about that unless you want to build a better linear better logistic regression module for Python, for example. Then you research something for years and you create something new in the industry. But if you want to operationalize stuff, if you want to create ML models, you just need to know a few terms. If you spend a few weeks or months, you will know all that you need to know about, okay, what is regression, what is overfitting, what is model accuracy, recall, precision, and then you can read the output of tools like Graphite Note, and you can bring additional value to your clients or company. I hope that kind of answers your question.
Yeah, it does. For sure. Thank you so much.
Thanks.
Paul also posted a question in the chat. I don't know if he wants to ask it himself or does he want me to read it out?
You can read it out. Thanks, Chris. Yeah.
Okay. So Paul says, great coverage of data science. How can you identify what other data would be useful to improve the accuracy of predictions and prescriptions?
Yeah, very simple, hard question and common. I would say start with everything you have. Then if you have like version 1 of your model, you will see what is relevant and what is not relevant. So maybe from 100 columns, you can go back to 20 relevant columns. And then you can use LLM for the question, hey, these are my 20 columns. What do you think I can do to improve, for my business use case, to improve maybe model accuracy? But because LLM can help you with generating ideas. And maybe one of the ideas will be start capturing something that you are not capturing right now. And that can be like eye-opener for you. Then you start capturing it. And 2 months later, you retrain the model with that column. And you see, maybe it will be an essential driver, it won't be, but that's usually the process. Sometimes you can enrich data from other external sources like weather forecast. That's what we do for product demand, for example, weather forecast. We classify weather from 1 to 5, or how heavy the rain was from 1 to 5, and you have Celsius or Fahrenheit temperature. And usually for this type of business use cases, if you are selling ice cream or renting bikes, it's a key driver is temperature, essentially. So that's how I would go about it.
Thank you.
Thank you.
No other questions from anyone?
Just generally about the costs involved with that application or other competitor applications.
Sorry, I didn't get the question.
The cost that's involved with Graphite Note. What's the cost and how is it charged, and what other competitor applications have you looked at?
We are charging a monthly subscription for our smaller plans. We have a most popular plan is Growth, where you can build 10 models on up to 10 million rows, and that's $9.95 per month. We have enterprise plans for big enterprises with lots of users and customers. Data rows. That's something custom in terms of pricing. And in terms of competitors in AutoML space, you have Quick AutoML, but you have to be tied on Quick. You have Azure AutoML, but then you have to be connected to Azure. There are some smaller players. What I would say Graphite Note excels is the explainability that we are offering after the model is trained. And this prescriptive piece is completely unique as of today. That's something that we provide, and as far as I know, no one else is. They're probably getting there, but I'm trying to be always on the forefront of research how to be better in this prescriptive area.
Thank you.
Thank you. You can always try, there's a free trial, you can always try to do something for yourself. And we have something called Impact in a Day. We are so confident that in one day we are going to build a model and present it back to you. So it's free of charge. So if you want to throw a challenge for us and you have a data, we'll do Impact in a Day for free for you, because we are that confident. So just reach out if you're interested.
Thanks.
Awesome. We'll move on. So the last section of the tug is, Harvey's contact details if you need those as well. So obviously graphitenote.com or LinkedIn or X, Twitter, depends on what you want to call it. But obviously it is a Tableau user group. So we'll get back onto the last section being Fast 5. So just 5 quick questions, quick answers. They're Tableau related. So I'll see. Here you go. There's no right answers or wrong answers. It's just personal feelings. So which Tableau feature makes you feel the most empowered when working with data, and why?
That's a question for me.
That's a question for you.
I remember when I was able to drop, okay, dimension and then measure, but then when I was able to drop dimension to color the flow chart differently based on the unique values of that dimension, that was kind of wow effect for me back in the day, but I still remember that effect.
Yep, that's good. Question number 2, do you feel more creative or analytical when using Tableau?
Then compared to the other similar tools.
Mm-hmm. And number 3 is, what's your go-to chart type in Tableau and why?
Chart type, definitely not a pie chart. Stacked bar chart. Why? I don't know, but in many cases, stacked bar chart, when it's not too heavy, can explain stuff more than plain bar chart with adding like another dimension. So I was using it a lot, and it's not just I used it a lot. It's people can still understand what they are seeing, because sometimes I really struggled to understand how people cannot understand like simple bar chart. But so short answer, stacked bar chart.
Well, the stack gives you the components and the total at the same time, basically. So that's the beauty of the whole thing. Yeah. Number 4 is, what part of Tableau feels the most fun to you?
Playing with again, it's around coloring. Like maybe that's the playful part, and colors are incredibly important. It's not just to create something, but then you can color something automatically based on unique values of something else or some thresholds. I think that's fun because it is creative in the end. So that's my answer.
Oh, that's cool. And the last one is, when exploring data in Tableau, do you feel more like a detective, an artist, or a builder?
Some of these questions are kind of similar. Like, oh, you want to check if I was true before, but it really depends on a client and a question. But that's maybe part of my personality, this artist type, and it's a good thing about Tableau. You cannot be too artisty, like to mess something completely. So artist, I'll go with artist.
Awesome. No, that's good. And to be fair on you, and to explain it to everyone else as well, I don't know what you're going to present. So these questions are just random questions that you haven't seen before. They're not linked to the presentation, which is why it sort of feels a little bit off kilter for today's presentation. But that's fine.
Okay.
Good. And that's why there's no wrong. There's no right or wrong answers here. It's just like, what do you feel like? Okay, if you feel more like an artist, then that's the right answer for you. That's fine.
I agree. Yeah.
Yep. Awesome. So thank you for your time. We'll just go over a few more. There's like 2 or 3 more slides left, and then that's the end of the meeting. So the next slide coming up is Shazira on Friday, I think it is. Yes, Friday, June the 6th, presenting Tableau Meets Comics, Data Storytelling Reimagined. So again, it's one meeting, it's all those times. So again, if you're in Europe, it's early in the morning. If you're in Australia, depending on where you are, it's sort of later in the evening. And the Americans get to wake up really early to see this awesome presentation. All the presentations that we do are all recorded and put on YouTube, the same as a lot of other online tugs. So you go to youtube.com, Team DataFam. There's also a podcast on Spotify and Apple, so you can listen to this rather than watching it. Obviously, for the presentation today, you probably want to watch it more than just listen to it, but you've got the choice there. And if anyone wants to present, make sure you email me at team.datafam@gmail.com, and we'll find a slot for you in the program. So again, Harvey, thank you for that. I got tremendous value out of it. I think a lot of other people will as well. It was a good explanation of machine learning plus how to apply it into not only your product, but just into general data and help people go, up the level of analytics as well. I thought it was good. Thank you.
Thank you so much. Let's keep in touch. Thanks.
Yep,
Thanks
definitely.
everyone. Bye-bye. Cheers.
Okay, thank you.